In this video, we are going to look at logarithmic differentiation. First thing is the situation, when do we apply logarithmic differentiation? If your function y looks like u to the power of v, where u and v are both functions of x, then it's done by logarithmic differentiation. So your question has to look like y is equal to u to the power of v, where both u and v are functions of x, or at least the power has an x in it, a function of x. Even if u is a constant, but the power has to be a function of x, and that's when we apply logarithmic differentiation. So what do you do for that? You take logarithm on both sides and then differentiate. So we're going to look at a question on it. Differentiate y is equal to x to the power of sine x. So this is y is equal to x to the power of sine x. So it does look like u to the power of v, where both u and v are functions of x. So this is under logarithmic differentiations. So what I do is I apply log on both sides. I apply log on the left side and I apply log on the right side. So that's log y is equal to log of x raised to sine x. This is a logarithmic property. Log of a raised to n is n times log a. Look at this property here. Log of a raised to n is n times log a. So if I have log of x raised to sine x, the power can come out, a log of a raised to n. The power n can come out. So it is n times log a. So this is sine x times log x. That's going to be a product there. So log y is equal to sine x into log x, and we are going to differentiate this with respect to x. So differentiating with respect to x, first log y derivative. Derivative of log y is 1 by y into dy by dx. And on the right side, it is sine x into log x, which is product, a product rule, u into v, uv rule. U into v dash plus v into u dash. So first function u into v dash, derivative of the second. So first function sin x into derivative of the second, derivative of v is v dash, which is 1 by x. So sin x into 1 by x plus second function log x into derivative of the first, derivative of sin x is cos x. So it is u into v dash plus v into u dash. And then I solve for dy by dx. So dy by dx is equal to I cross multiply y to the other side. So y into sin x by x plus cos x into log x. And then finally I replace y by its value. The value of y is x raised to sin x into sin x by x plus cos x times log x. Another question now. So this is differentiate y is equal to sin x to the power of x plus sine inverse of root x with respect to x. So differentiate this function with respect to x. And when we analyze this question, we realize that the first term here looks like u to the power of v. Sin x to the power of x, u to the power of v, where both u and v are functions of x. So this term is under logarithmic differentiation. The second term, sine inverse of root x, is just sine rule. I'm sorry, it's the chain rule. So the second term is just the chain rule. The first one is logarithmic. And if one of the terms is logarithmic, we treat the entire question as logarithmic. But the problem is that I cannot apply logarithm on this function. I cannot apply logarithm because there is addition, and log of a plus b is not the same as log a plus log b. Log is not distributive over addition. So I cannot apply logarithm on this. So what I am planning to do is do these two terms separately, differentiate the two terms separately and add it up. So what I'm going to do for that, I'm going to call this question as each of this function as u and v. So y is equal to u plus v. I call the first function as u and the second function as v. y is equal to u plus v. Therefore, dy by dx is equal to du by dx plus dv by dx. dy by dx is equal to du by dx plus dv by dx. Then I start with u. U is sin x raised to x. So which is logarithmic? So we apply log on both sides. So that's going to be log u is equal to log of sin x raised to x, and then that's like log of a raised to n, and power n can come out. So that's going to be log u is equal to x times log sin x. And now we differentiate this. So when you differentiate it with respect to x, on the left side it is log u, derivative of it is 1 by u, log u derivative is 1 by u into du by dx. But on the right side it is product rule of differentiation. So we say first function into x into derivative of log sin x is 1 by sin x into the inner derivative cos x. So first function into x into derivative of the second derivative of log sin x is 1 by sin x into the inner derivative cos x plus second function into the second function is log sin x to the derivative of the first derivative of x is 1. So I solve for du by dx, and so I get du by dx is equal to u times x into cos x by sin x. I write as cot x. The next term is log sin x, and of course I need to replace u by its value. So sin x raised to x into x cot x plus log sin x. That's my du by dx. I still have the second term sin inverse root x, which I took as v. So I say v is equal to sin inverse of root x, which is simple chain rule. So dv by dx is equal to, what's the derivative of sin inverse of x? Sin inverse of x is 1 by root of 1 minus x square. So what's the derivative of sin inverse of root x? Sin inverse of root x would be 1 by root of 1 minus root x the whole square. But it's not finished, into the inner derivative because it was not x inside. So 1 by root of 1 minus root x the whole square, which I have put as x, into the inner derivative, derivative of root x, which is 1 over 2 root x. So that's my dv by dx, and then I'm going to put this back into equation number 1 to find my dy by dx, and dy by dx will be du by dx plus dv by dx, and I have got both the answers done separately. Add them up. Dy by dx is equal to du by dx answer I copy, plus then I copy the dv by dx answer as well, which is my complete derivative. I'm going to look at another question. Find dy by dx if y is equal to log x raised to x plus x log x. Same situation. It is logarithmic, not that it has got log in it, no. Because it looks like u to the power of v, where u and v are functions of x, you have a variable in the power, and even in the second term, x to the power of log x, the power has x in it. So if there is variable in the power, it's going to be logarithmic. So it's like u to the power of v, where both u and v are functions of x, it's under logarithmic. But I cannot apply logarithm directly because there is addition. So I'm going to call them as u and v. So I'll say y is equal to u plus v. So to differentiate, dy by dx will become du by dx plus dv by dx, differentiating with respect to x. Dy by dx is equal to du by dx plus dv by dx, equation number 1. I'll leave it there, and I'm going to start with u now. U is log x to the power of x, and I apply log on both sides. So I'll get log u is equal to log of log x raised to x. That's like log of a raised to n. So n times log a. So that x is going to come out. So log u is equal to x times log of log x. At this stage, I differentiate with respect to x. I say differentiating with respect to x, log u derivative 1 by u into du by dx is equal to, right hand side is product rule, x into log of log x. X is the first function and log x is my second function. So first function into x into derivative of log x, derivative of log x. Log of f of x is 1 by f of x into f dash of x. So log x is 1 by log x into the inner derivative. Derivative of log x is 1 by x plus second function into log x into derivative of the first, and derivative of x is 1. But here this x and 1 by x will get cancelled, and I cross multiply u to the other side so that I can find what du by dx is. So du by dx is by u goes to the other side and becomes u into what I have on the other side. Here x and 1 by x had cancelled, so 1 by log x plus log x. And finally, I replace the value of u, which was log x raised to x. So log x raised to x into whatever I have in that bracket, which is my du by dx. I still have to work on v, so I'm going to work on v. And what is v? X raised to log x. So let me copy that function. V is equal to x raised to log x. This is again logarithmic because you have u to the power of v, where both u and v are functions of x. So we say applying log on both sides. So we get log v is equal to log of x raised to log x, and the power can come out now. So we get log x times log x. The power log x comes out. But log x into log x is log x the whole square. So I'm going to differentiate now. Differentiating with respect to x. What's the derivative of log v? Log x is 1 by x. Log v will be 1 by v into dv by dx because I am differentiating with respect to x. So log v derivative is 1 by v into dv by dx. So the right hand side is log x the whole square is 2 times log x into the inner derivative is 1 by x. And now I cross multiply v. So dv by dx is equal to v into 2 log x by x. Put the value of v back in, which is x raised to log x into 2 log x by x. So I go back to equation number 1 and write what my dy by dx is. dy by dx is du by dx plus dv by dx. And I copy both the answers. I copy my du by dx plus my dv by dx, which I got here, which is the answer. Okay, look at this question now. If x raised to m into y raised to n is x plus y the whole raised to m plus n, prove that d square y by dx square is equal to 0. In fact, if you analyze this question, you will realize that it is not logarithmic. It's a simple product rule, chain rule kind of a question, also implicit, because none of the terms here are in the form u to the power of v, where both u and v are functions of x. No, the power is m here, it's n here, and it is m plus n there. They are all supposed to be constants. So it is not under logarithmic. Now what is so important about this question is that but logarithm makes this question so much more easier for us to do. So we are going to treat it, although it is not a logarithmic differentiation question, we are going to apply logarithm on this to do this. So I copy this question and I'm going to say take logarithm on both sides, applying log on both sides. So log of LHS is equal to log of RHS. But on the left side I have log of a into b, and log of a into b will be log a plus log b. Also the power will come out. So what is it going to be? It's going to be m log x, then multiplication becomes addition, plus power comes out, so n log y. So m log x plus n log y is equal to, on the right side, log of x plus y to the power of m plus n. The power can come out, so it's going to be m plus n times log of x plus y. The power m plus n comes out, m plus n times log of x plus y. So now we say differentiating with respect to x. So differentiating with respect to x, m log x, derivative of m log x, m is only a coefficient, into log x derivative is 1 by x, and you are done with that, plus n log y, n times log y is 1 by y into dy by dx. On the right side, there is m plus n as the coefficient, so which I have to copy first. That's the coefficient. And what's the derivative of log of f of x? 1 by f of x into f dash of x. So what's the derivative of log of x plus y? 1 by x plus y into f dash of x, the inner derivative. And what's the derivative of x plus y? There are two terms, so it has to appear in a bracket. X becomes 1 and y becomes dy by dx. I'm going to slightly rearrange this. So m by x, m into 1 by x, m by x, n into 1 by y, I wrote as n by y, dy by dx. is equal to m plus n into 1 by x plus y, I wrote as m plus n by x plus y. But what I'm going to do is, with that m plus n by x plus y, I open the bracket, multiply inside. So m plus n by x plus y into 1 will give me m plus n by x plus y, plus again m plus n by x plus y into dy by dx. So take this m plus n by x plus y and multiply both the terms inside. So you get two separate terms like that. Now, if you look at these highlighted terms, two of them, they both have dy by dx. So I'm going to get them on the left side. So I'll have dy by dx common, n by y here, and when I bring this term to the left side, it becomes negative, and I took dy by dx out. So I have n by y minus m plus n by x plus y is equal to the rest of the terms, this term and m by x, which I shift to the right side like that, yeah, on the right side. So what we did at this stage is we collected both the dy by dx terms together on the left side and the remaining terms on the other side. We copy this one more time here before I take LCM. So that's the step we reached, and I'm going to take LCM here. LCM will be y into x plus y. There the LCM will be x into x plus y, and of course you will cross multiply. So you get dy by dx into LCM is y into x plus y, and I cross multiply x plus y. So what do I get? N into x plus y minus this y goes up there, y into m plus n is equal to right side. The LCM is x into x plus y, and you cross multiply, x will go up like that. So x into m plus n minus m into this x plus y goes to the other side, minus m into x plus y. Look at that, x into m plus n minus m into x plus y. You can see that there is this x plus y in the denominator on both the sides. They are going to get cancelled. See, x plus y are cancelled from both sides. Then I'm going to open the bracket. So when I open the bracket, I get nx plus ny minus my minus ny. Just simply opening the bracket upon y. So there, if I open the bracket, I get mx plus nx minus mx minus my by x. Just opening the bracket. Mx plus nx minus mx minus my by x. Now see what's happening here. There is an ny here and a minus ny, which will cancel. Here there is an mx here and a minus mx, which will cancel. Let's write the rest of the terms. So those terms are cancelled. The remaining dy by dx into nx minus my upon y is equal to right side nx minus my upon x. And you can see that the numerators are exactly the same and they get cancelled. So what's your dy by dx? Dy by dx is y by x. Sometimes they only ask for dy by dx. Dy by dx is y by x. But in my question, I had asked for second derivative, the higher order derivative, second derivative, differentiated one more time with respect to x. That's d square y by dx square. So when I differentiate it second time, on the right side what I have is y by x, which is quotient. Quotient rule. V into denominator into u dash, v into u dash minus u into v dash by v squared. Denominator into derivative of the numerator minus numerator into derivative of the denominator by square of the denominator. That's x into denominator into derivative of the numerator dy by dx minus y into numerator into 1 derivative of the denominator. Look at that, u into v dash. V dash is dy, no sorry, it's v into denominator into u dash, derivative of the numerator, derivative of y is dy by dx, minus u into y into v dash. V dash is derivative of x is 1 by v squared. But into this, we already know what y by x is. Y by x is, I'm sorry, dy by dx. We already know what dy by dx is. Dy by dx is y by x. Replace dy by dx by y by x. So you get x into y by x minus y by x squared. If you cancel this x and x here, you have y minus y, which is 0. So d square y by dx square is 0. I'm going to do one more question on the same thing, same idea, same concept, but the question looks different. It's basically for practice. So what you could do is, you could pause the video at this stage and try it to yourself and then come back and watch. Okay, I'm going to discuss this. First, I copy the question. That's my question. X raised to 16 into y raised to 9 is equal to x square plus y the whole raised to 17. I say taking log on both sides. So log of, it's basically almost the same as the previous question, you see. Log of x raised to 16 into y raised to 9 is equal to log of x square plus y the whole raised to 17. On the left side it is multiplication, and the multiplication will change. Okay, so on the left side, this log of a into b becomes log a plus log b. So log of x raised to 16 into y raised to 9 becomes log a plus log b. But at the same time, the power comes out. So log of x raised to 16 is 16 log x, plus multiplication becomes addition. And log of y raised to 9 becomes 9 log y. So equal to here, 17 comes out. 17 times log of x square plus y. And now we differentiate this with respect to x. So differentiating with respect to x, 9 into 16 into log x is 1 by x, plus 9 into derivative of log y is 1 by y into dy by dx. On the right side, it is 17 times log of x square plus y. Log of x square plus y is 1 by x square plus y into the inner derivative. But when you try to do the inner derivative, there are two terms. So it has to be in a bracket. So inside the bracket, x square becomes 2x and y becomes dy by dx. I'm going to slightly rearrange this. So 16 by x plus 9 by y into dy by dx, and this outside term, 17 by x square plus y, I will multiply inside. So 17 by x square plus y into 2x will be 34 x by x square plus y, plus 17 by x square plus y into dy by dx. Now we are going to collect the two dy by dx terms. I have one dy by dx here and one dy by dx here, and I'm going to collect them together on the left side. So dy by dx common factor into 9 by y, and from the term which I bring to the left side, I have minus 17 by x square plus y is equal to the remaining terms, 34 by x square plus y, and the 16 by x goes to the other side and becomes minus. Then we take LCM. LCM on the left side is y into x square plus y, and I cross multiply. So 9 into x square plus y minus 17y. On the right side, the LCM is x into x square plus y, and you cross multiply. X into 34x is 34x square minus 16 into x square plus y. And you can see that, okay, let me just copy this same thing on the other side one more time. And then I can see that this x square plus y is the same on both sides in the denominator, and so they are going to get cancelled. So that's how I cancel this denominator like that. Then I open the bracket. So 9x square plus 9y minus 17y, only y in the denominator. 34x square minus 16x square minus 16y by x, which on simplification, 9x square minus 8y by y is equal to 34x square minus 16x square will be 18x square minus 16y by x. So now there is a common factor 2 on the right side, so I'm going to take that out. Left hand side I copy the same, 2 times 9x square minus 8y by x, and then you can see 9x square minus 8y and 9x square minus 8y, the numerators are cancelling. So just send this 2 to the other side, so it becomes 2y by x. But your question was on second derivative, so we are going to differentiate it one more time. So d square y by dx square, quotient rule, v into x into derivative of the numerator, derivative of 2y is 2 dy by dx, minus numerator into 2y into derivative of the denominator is 1 by the square of the denominator, v square, which is x square here. But we already found what dy by dx is. So we copy that value from there. So it is x into 2 into dy by dx is 2y by x minus 2y by x square. X and x cancel, so you get 4y minus 2y, which is 2y by x square, 2y by x square, which is your answer. So what you need to do is, you should go back and copy down all the questions what we have done and then try to redo it yourself. So that's from logarithmic differentiation, and in the next video we will look at parametric and second order derivative questions.